Good day everyone, I am Jordine P. Florendo and today I am your teacher in Basic Electronics. So before we start our lesson, can I ask everyone to please stand up? Miss Kabugao, can you lead the prayer? Amen. So before we start our lesson, class monitor, can I have the attendance? Is there anyone absent? None? Okay, thank you. So, good morning class. So, can anyone in the class tell me what was our lesson last meeting? Anyone? Yes, Mr. Manikens. Resistor color coding, correct. So, how about the memory guide used in resistor color coding? Any other hands? Yes, Mr. Desana. Okay, correct. So, how about the color equivalent of our memory guide? Yes, Miss Kabakungan. Okay, correct. So, how about, for example, we have a 4-band resistor. What does the first color represents? Any other hands? Yes, Miss Baladat. First digit, correct. So, how about the second color? Miss Galate. Second digit, correct. So, how about the third color? Anyone? Any other hands? Yes, Miss Galate. B, multiplier. Okay, correct. So, how about the fourth color? Tolerance, correct. So, very good class. It seems that you are paying attention in our discussions and it seems that you are now ready for our next lesson. So, before we start, as you can see, I have two electronic instruments in front. These electronic instruments. So, does anyone in the class know what these are? Does it look familiar to you? It looks familiar, okay, correct? So, as I have said, these two are electronic instruments. So, maybe you are wondering, Ma'am, can I get electrocuted if I use these electronic instruments? Well, to tell you class, you cannot get electrocuted when you use these instruments because these are all well insulated. So, since everyone seems not too familiar with these electronic instruments, we are now, for today, we will talk about the multimeter or multitester. So, before we go on, let us first define what is a multimeter. So, anyone in the class? Volunteer to read? Yes, Miss Galate. Okay, very good. As it has said, a multimeter is a multifunctional electrical measuring instrument which has a main function of measuring characteristics of electric signal. So, it has a function. So, what are the functions of multimeter? So, we have three. These are the voltmeter, ohmmeter, and ammeter. So, first, let us talk about voltmeter. Can anyone please read? Yes, Mr. Desara. Okay, thank you. So, as I have said, a voltmeter it has something to do with volts. So, a voltmeter measures what? It measures the volts that is present in AC and DC circuit. So, just a brief recall class. What is an AC or DC? Anyone? Yes, Mr. Maniquez? Okay, correct. So, an AC stands for alternating current and the DC stands for direct current. So, next we have another function, the ohmmeter. Can you please read, Miss Baladat? Okay, thank you. So ohmmeter, it has something to do with the resistance, electrical capacitance, and inductance. So in ohmmeter, the unit is what? The unit is about ohms because it measures resistance. Then next we have the ammeter. So what is an ammeter? Can someone read? Yes, Mr. Rosada. Okay, thank you. So an ammeter measures direct and alternating current. So for us to be able to understand more, voltmeter is for volts. And ohmmeter is for resistance, inductance, and capacitance. And ammeter, it has something to do with amperes. So next is the type of multimeter. So as I have said a while ago, I have two objects in front. So can you class determine which is the analog and the digital one? Any idea? Yes, Miss Kabahungan? Are you sure? Okay, so let's find out if you are correct. So here we have, first, let's talk about analog multimeter. So what is an analog multimeter? Can you please read? Miss Umaweng? Okay, thank you. So an analog multimeter, the value that is being measured is indicated or showed in what? Showed in? It is not direct, it is not digital. So it means that the measurement or the values that being measured is indicated by a pointer that moves over a scale, which is when you calibrate. So this is an analog multimeter. So as you can see, there is the pointer that moves over the scale. So this is the pointer. These are the scales where the pointer moves. This moves only when you calibrate it. So next we have the digital multimeter. So what is a digital multimeter? Yes, Mr. Losara. Okay, thank you. So a digital multimeter is the value being measured is indicated through a direct reading displayed in numerical figures. So it means that a digital multimeter is more advanced because the measurement and the values are being indicated or showed in digits in this one. So this is an example of digital multimeter. So next, we have the parts of analog multimeter. So there, as you can see, we have the pointer here, the scale, which is indicated by numbers, the infinity knob, 0 ohm adjuster, ranges, the range selector, and the test probes, which has negative and positive. So here, as you can see, take a look, class. So this is the needle pointer. These are the scales. This is the infinity knob. The infinity knob, it adjusts the pointer to 0 and infinite resistance. So next we have the 0 ohm adjuster. The ranges. These are the ranges. DC, AC, like that. So these are the range. This is the range selector when we can calibrate it like this, depending on the value you need to measure. And the test probes. For the test probes, we have the red one as the positive, just like this one. Red one as the positive and black for the negative. So, is there any question with the parts of analog multimeter, class? None? Okay. So next, we move on to the parts of digital multimeter. So here we can see the parts of digital multimeter, the same as this one. So we have the display, the digital display where you can see the value indicated by the measured value, the hold button, the rotary switch, these are the ranges, and the port for negative and positive test probes. So here, take a look, class. So this is a digital multimeter. As I have said before, this is the display, the hold button, the range selector, the same as the range selector in analog multimeter. These are the ranges. And this is for negative test probe, which is the black one, and the positive test probe, the red one. So next, we have the scale. So, can you follow, class? Is there any questions? Okay. So next, we have the scale. As you can see, that is the zoomed part of the scale. So this green one is for ohmmeters. This black one is for DC or AC, for voltmeter and ammeter. So this red one is also for voltmeter, although it is just for the range 10. So the black one is for the ranges 50 and 250 and 1000. So first, we have the ohmmeter scale per division. So there, you can see. So from 0 to 1, we have 0 0.2, 1 to 2, 0 0.2, 2 to 5, 0 0.5, from 5 to 10, 0 0.5, 10 to 21, 20 to 32, 30 to 52, 50 to 100 is equivalent to 5, 100 to 200 is equivalent to 20, and from 200 to small, the small line, the 50, and 200 to big line is 100. And 1K stands for 1000, 2K for 2000. So let's take a look back to this scale. So here, so as I'm saying, from this one, so this is the ohmmeter scale. So the divisions are, as I've said, 0 to 1, 1 to 2, 3 to 5, like that. So did you follow, class? Is there any question? Okay, so let's move on to the AC voltmeter. So for measuring volts, these are the ranges. So for measuring the volts in AC voltmeter, we will use the black scale a while ago. So this is the black scale. There. This is for voltmeter. The ranges is from 50 to 250. But for 10, we will need to use the red one. So these are the ranges. For 10 volts, we have 0.2 volts per division. 50 volts is equal to 1 volt per division. And 250 volts is equal to 5 volts per division. And 1000 volts is equal to 20 volts per division. So DC voltmeter. So as you can see, this part is the same as in the AC voltmeter. So the only difference is it has these ranges. So we have 2.5 volts for, which is equivalent to 0.05 volts per division. 0.25 volts is equal to 0.005 volts per division. And 0.1 volts is equal to 0.002 volts per division. So there we have it. and 1K less, that one. So next we have the milliammeter. So these are the ranges. So for milliammeter, we will use the black scale again. So we have these ranges. 50 milliammeter is equal to 1 milliammeter per division. 2.5 milliammeters is equal to 0.05 milliammeters per division. 25 milliammeters is equal to 0.05 milliammeters per division. And 0.25 amperes, which is also equivalent to 250 milliammeters, is equal to 5 milliammeters per division. So, can you follow, class? Is there any questions? Is there any questions, class? None? Clarifications? Violent reactions? Okay. So, before we proceed with the application, again, a multimeter is an electronic instrument that measures the electric signals present in an AC or DC circuit. So we have the three functions of multimeter or multitester. It is the what? Voltmeter, ohmmeter, and ammeter. So there are also two types of multimeter or multitester. These are the analog and digital. So this is again the analog and this is the digital. Any more questions, class, before we go on to the activity? None? Okay. So let us now proceed to your application. But before we go on with the activity, let me show you how to calibrate a multimeter, which is we will use the analog one. So, okay, so for example, first we need to adjust the pointer to 0. So we will use the voltmeter. So in voltmeter, the 0 is located at the left side. So the pointer must be in the left side. So this is the 0 ohm adjuster. So we need to, so as you can see, the pointer is in 0. Then next, you have, or if it is not in 0, you need to do this. Short circuit the two test probes so that the scale will show 0. So for example, you want to measure a DC. So these are the examples of DC circuit, the two batteries. So as you can see, a battery has a 1.5 volts. So first, since our multimeter or multitester is in off position or off state, we need to turn it on. Remember that you want to test a DC, so you need to put the range in DC. If ever you are testing a DC and the range is not, the range or the measurement or the value is not present, for example, there is no value in there, so you will put the range selector in the highest range. Always put it in the highest range to avoid risk, to avoid damage of the electronic instrument as well as for your safety. But if the measurement or the value is shown or present, like that one, 1.5, so you need to put it in the range where it belongs. So we'll put the range under or just in 2.5 volts DC. So let's try. So as I have said before, the red one is for positive and the black one is for negative. So you need to find where is the negative side. So this is the negative side and the positive side. So you will put the the negative side, the negative test probe on the negative side, and the positive for positive. So take a look at the, so just like that. So as you can see, it is not stable because it is an analog. So for a stable measurement, you need to wait for it for a couple of minutes or some seconds. So if ever the pointer goes in between the lines, what will you do? What will you do, class? So what will you do is, whatever line is nearest to the pointer from 0, so that will be the measurement that you will take or take note. So again, so as you can see, the pointer is in 6. So how to solve it? Mentally or what? If you have calculators. So as I have said before, a DC voltmeter, in DC voltmeter, so you have 1.5 volts, so the range is 2.5. So in 2.5, how many divisions, how many volts per division? It is 0.05. So as we can see a while ago, the pointer goes in 6. So each division is 0.05. So we have 5, 10, 15, 20, 25, 30. So because in per division we have 5 lines, right? So from 0 to 6 we have 30. So 30 times 0.05 is equal to 1.5 volts. Did you understand, class? Okay, so class, for you to understand on how we got the value of this battery, or on how we got the measurement 1.5 volts. So for instance, this is the scale. So we have the per division is this one. So we have 4. So this is 0. Okay, so a while ago we have used the range 2.1. Okay, so a while ago we used the range 2.5. So as we have discussed a while ago, that in DC voltmeter, the range 2.5 is equal to what? It is equal to 0.05 volts per division. So what do you mean by per division is these lines. So 0.5, this line is 0.05, also with this line. So 0.05 plus 0.05 is 0.05 plus 0.05, we have 0.05. We have 0.10. 0.10 plus 0.05 is 0.15, 20, and we have 0.25. So again, 0.25 plus 0.05 plus 0.05, and so on and so forth. So we got the or 0.50, 0.75, and 1, 1.25, 1.50 or 1.5, 1.75, 2, 2.25, and 2.5. So as you can see, the last division will be the same as the range. For you to check if your scale is correct, the last division will be the same as your range. So for instance that the range is present, which is 2.5 volts, but you do not know the volts per division or the scale. So what is the formula? We have the range, which is 2.5 divided by anyone in the class? Range divided by 50 is equal to number of division or number of volts per division. So there it is 0.05. So for our example a while ago, we have seen that the pointer goes in the sixth line. So we have here 1, 2, 3, 4, 5, 6. So the pointer points here. So as you plotted your scale, you can now measure, or you can now locate what is the value of the pointed arrow. So since the pointer goes here, it is equivalent to 1.5. Did you get, class? Is there any questions? Okay, so if there is no other questions or clarifications, so let us now proceed to your application. So since we have the limited number of electrical instruments or the multimeter or multitester, I will group the class into 3 groups. So starting from the one from the right in front, kindly count 1 to 3. Okay, go. Okay, thank you. So what was the last number? Okay, so you will now go with your group, and each group will have a turn to measure the devices or the electronic components in front, and each group must have their secretary. So one activity sheet or one evaluation sheet per group, and you will have your secretary to pass the paper to me afterwards. So are you all set? Okay, you may now start, class. You have 15 minutes to finish. Are you all done? Okay, kindly pass the papers. Thank you. So that is all for today. Thank you, class.